Today we're going to talk about radian measure, so let's get right to it. So far we've measured angles using degree, and so the degree of an angle is the amount of rotation, and we know that if we go one time around the circle, we've gone 360 degrees, and that's one complete turn. Sometimes we use the word revolution. So what is a radian measure? A radian is the measure of the arc along the circumference of the circle. Okay, so let's go ahead and I'll go ahead and draw a circle here. We have a central angle theta with a radius of r. When the radius r is the same length, and it's hard to determine exactly because on the circle the radian curves, when these measures are the same, we say that theta is equal to 1 radian. Okay, it's kind of confusing at first, but I promise you'll get the hang of it. So we need a way to find the radian measure of any central angle theta. So if we have theta, the radian measure is equal to s, and that's what we use. Let me start that over again. To find the measure of theta, any central angle, what we do is we take s, which is the arc length, and we divide it by r, the measure of the radius. So let me do a quick example of what I'm talking about here. Let's say I have a circle and the radius is equal to 3, and s, the arc length, is equal to 6. So going back to this picture, if I guess I should draw a different picture. So this time I have a different theta where this is equal to 6. Right? The radius is 3, and so theta will be the arc length divided by the radius measure, and so theta is 2. Now that's kind of a funny way to look at an angle, and so I have to make a note here that 2 degrees is not equal to 2. We don't always put the word radians in. Okay, we imply that it's there. So if we see 2 as a measure of an angle, we know we are in radians. And how do we know we're in degrees? Well, the only time we're in degrees is if we see the symbol. Okay, so now we need to come up with a process to change quickly from degrees to radians, and then also radians to degrees. Okay, so we're going to start here and we're going to go back and say that 360 degrees is 1 turn, and 1 turn in radians is 2 pi r, the circumference of the circle, right? You remember that from geometry. Okay, now what that means visually, maybe this will help, is that if the radius is equal to 1 and I were to take that radius of 1 and wrap it, so here's 1 radius, and here's a second radius, and here's a third radius. If I were to wrap all the way around the circle, it should not be surprising that there would be about 6.28 of the radii that would wrap around the circle, and that number should look familiar. That's the circumference estimated of the circle. Okay, you know it is 2 pi. Right, when r is 1. Okay, good. Let's go ahead and get down to it. How is it that we change? We'll start with degrees. So I want to know 60 degrees is how many radians? Okay, so we know that 360 degrees is equivalent to 2 pi radians. We're going to make this easier and say that that's the same as saying 180 degrees is pi. So we can change 60 degrees to radians by setting up a proportion. Everybody loves a proportion. So on the left side we start with pi is to 180. And then we just have to make sure that on the right side, since we have radians on the top and degrees on the bottom, that we put degrees on the bottom, and then we'll go ahead and put our variable there. So we solve this by saying 60 degrees times pi is equal to 180 degrees times x, and when we divide both sides by 180, we get that pi over 3 is the equivalent radian measure of 60 degrees. Okay, let's see why that makes good sense. And it always helps when we do these to have a visual. So this is 180 degrees, which is pi radians, right? And so 60, if you look at a 60 degree angle, it's pretty easy to see that 60 degrees is 1/3 of 180. And so it would make sense that 60 degrees is 1/3 of pi. All right? Hopefully that's helpful. Using that manner, I hope that you can see that 120 degrees, if you were to guess that 120 is two of those 60s, and so 120 turns out to be 2 pi over 3 radians. At some point, you're going to want to have, oh, those were my dogs, these memorized. All right? Let's go ahead and go the other way. What about if I give you a degree radian measure and I want to go the other direction? So let's go ahead and let's say pi over 3, I want to change to degrees. All right, so using the same proportion, pi is to 180 equals pi over 3 to x, right? And so when I cross multiply, pi x equals 1/3 of 180 is 60 pi, right? Oh, that's the same one that I did. Huh, that's okay. Divide both sides by pi, and what we get is that 60 degrees is equivalent to pi over 3. All right, perfect. Now, you guys are smart and can handle this. I know you like shortcuts. Just make sure that you use the shortcut correctly. You can always go back to that proportion, but here's my shortcut for changing. If I have degrees and I want to go to radians, I take the degree measure and I multiply times pi and divide by 180. There's a lot of reducing of fractions when we do that. Likewise, if I have radians and I want to go to degrees, I'm going to take radians and this time multiply by the reciprocal of that fraction. And that gives me, so that gives me radians, and radians times 180 degrees divided by pi is equal to degrees. All right? And so last thing I want to leave you with is that sometimes our radians, like in that first problem, are not do not have pi in them. And so if I tell you I have 3.1 radians, right, to change it to degrees, 3.1 times 180 divided by pi, you might be saying, how can that be radians? There's no pi that I see. And that simply means that the pi has been multiplied in. And so what you're going to do is simply put it in your calculator, give a decimal representation. There you go. We'll practice this in class. See you.